All right. Good morning, everybody. My name is Greg Michelson. I'm one of the co-founders here at Zerve, Chief Product Officer. Got the music going in the background. All right. All right. Today's topic is coding agents, particularly as it relates to data science. I was just listening to a podcast this morning from The Daily, and they were talking about all of the crazy holes that people are falling down as they're talking to large language models. Seems like they're everywhere in the news these days. I just used ChatGPT to come up with a recipe for hot honey mac and cheese. It was absolutely delicious. So I go back and forth between thinking that large language models are just kind of the smartest dumb chatbots that have ever been invented, or something really, really different. I'm joined by Jason Hillary, one of our other co-founders here at Zerve, Chief Technical Officer. Jason, say hi. You want to introduce yourself a bit?
So hi everyone, and hi Greg. So looking forward to kind of the next hour. It's been a long-standing thing in Zerve to try and get you on a podcast, so this is kind of the first step towards it.
Well, it should be a good conversation today anyway. But like I say, every time you turn the news on, every time you're reading on LinkedIn, everything's about AI, everything's about large language models, and maybe the biggest impact that these guys have had, these large language models, is in the space of coding, in the space of writing code, because it turns out large language models are super good at writing code, and that's impacting everybody in this space. Somebody who isn't. Oh, sorry. Go ahead, Jason.
Oh yeah, just on that, it's kind of a killer application for like agents in general. Is the coding side of it, especially with the likes of Claude, just pretty much focusing on coding in general. It's like that's kind of their killer niche.
It certainly is changing the way that people write code today. It certainly changed the way that I write code. Someone who isn't here with us today is Philly Hayes. He was supposed to be here, so I know his fan club and entourage are disappointed that he's not here. He's a bit under the weather, so we're sorry that our other co-founder and CEO aren't here. Everyone's very disappointed, and I'm sure we'll suffer in comparison, but we shall bravely soldier on. It's 9 a.m. for me here on the west coast of the United States, and Jason, what is it for you?
It's 5 p.m. here on the west coast of Ireland.
Nice. Okay. Well, we truly are multicultural here. Well, before we dive in, Jason, I want to make sure we're all sort of starting on the same page. Can you just talk a little bit about what coding agents are? Like, what do I mean when I say coding agents, so we can all kind of get on the same page?
Yeah, so I think everybody kind of has been exposed to like large language models and what they're able to do through ChatGPT. And I think the core thing with an agent and a coding agent in particular is like its agency or its autonomy to do tasks kind of end to end. So it's where it all would have started with GitHub Copilot and kind of like the autocomplete, and then people would have like migrated to using ChatGPT to enter a prompt, give it extra context to get some code it could copy and paste into its code editor, run the code and iterate that way. Coding agents get much closer to the code and often run inside of your IDE or your terminal, and they're able to kind of go end to end from planning to debugging to testing to execution, and they're able to iterate. So able to actually like work on the code, have full context of your code base, access to tools like running the code, accessing the terminal, installing packages, everything like that. So being able to like autonomously act as if a developer would inside of your IDE.
That sounds dangerous.
Yeah, but fun.
Yeah. Dangerous but fun. That's like our slogan here. How do you, so I'm not an engineer. You know, I'm not an engineer. I'm a data scientist. I write code from time to time, but it's always bad code, as with most data scientists. In fact, I remember one of the first events we did at Zerve, we were talking about how using Zerve to develop data science could help people code better because it makes you think in a modular way, and the code is organized as a graph and stuff like that. And one of these data scientists in the room stood up. This was in Eindhoven in Europe. And he goes, well, why can't you just make data scientists be better coders? And I was like, good question. I don't know the answer to that question. And I don't know if large language models actually make anybody better coders, but
I think what they can do is like standardize kind of like code quality across it anyways, because it's all like effectively the same models writing 90% of the code. There is a thing as well where in a lot of data science projects, like optimizing too early can be a problem. So like bad code that works isn't always the worst thing to start with. So it's like you might be throwing it all out in like a couple of hours time anyways.
That reminds me of an argument I have all the time at home. I like to, when I load the dishwasher, I don't like to pre-scrub the dishes. Ooh. And I always get yelled at because some of them don't get clean. And I'm like, hey, a lot of them did get clean. So that's kind of like bad code that works.
I'd be on the other camp. I would have grown up, pre-washing, doing the dishwasher's work for us.
Yeah, I don't like that. I don't like that at all. How have engineers kind of adopted these things? Do they like coding agents? Do they view them as invaders or as a threat to their work, or what's the sense?
Yeah, I think it's like people have like adopted it. It's taken a while. There was like early adopters, like most things, and then there was like some people that were very skeptical how people like to write code. And there's like some interesting like patterns where we've heard of like developers who use the autocomplete features in the likes of Cursor but never accept it and will like rewrite the code themselves even if they like it. So I'm not 100% sure the benefit of it, but that's kind of like a lot of people have found some like interesting ways to work with it. And then there's more recently, I think the likes of like Cloud Code is like more agentic than like autocomplete or like the tab functionality in Cursor, and it's gotten like good adoption. I think there's like a prevailing sense that it's the future, like it's here and it's probably here to stay.
Yeah, I've always found the autocomplete things to be very distracting, and like the user experience, like the actual interaction with the models is very clunky and hard, it kind of interrupts your flow a bit.
Yeah, I would have. It's like, or you just kind of like sit there and wait, like watch the cursor blink for a few seconds just for it to fill in something. It can be good to unblock you a little bit, but I would have found a lot of the time I would have still used like ChatGPT or something like that to create the code that I would copy back in and then like kind of go back and forth to debug.
Yeah. Now, I've also one of the other things I found is when you use these coding agents that they tend to be good at starting projects and at kind of jump starting and giving you some boilerplate and getting some foundation built, but they struggle a bit when it comes to like working on a project that's already partially done. Why is that?
Well, a lot of it is probably to do with context and like just being able to find the right like context within inside a code base or maybe like yeah, just not being able to deal with larger context in general. I think models are getting better. It's like if you have larger context windows and they have like less of a tendency to forget the top of the file, we'll say, then before, but it's still somewhat of an issue where, and you do get like hallucination still. So I was using it on front end code, so not data science code for this particular project, and it hallucinates like it's kind of like styles all the time. Just puts in like colors that it thinks should be there that aren't actually there and things like that. So it's like yeah, so it can get like infuriating sometimes for when you think it's easy, that it can yeah, kind of like struggle.
That's funny. I was actually using ChatGPT to write a query to use the OpenAI API to submit requests, and it invented an API. And when I pointed out that that API didn't actually exist, it said that it should exist.
Well, it has a point. It's like, yeah, it's so I see we have a question in there, Greg. It's like maybe one that we were kind of like maybe planning to get to at the end, but it's like probably a hot topic. So I don't know if it's one that you want to kind of tackle from the start.
All right, let's see. It says if context aware agents succeed, what roles or tasks for data scientists do you think will disappear, and which ones will become more important? Good question. What do you think, Jason?
I think there's yeah, if you kind of think about what the world could look like if there was like agents that could kind of go end to end on lots of tasks. For data scientists, I think a lot of the value could be in like experimenting like much quicker. In terms of being able to try a lot more like experiments in parallel. So there's somewhat like supervision of like multiple agents becomes like and the ability to like quickly switch contexts becomes like important. I do see a world as well where agents don't just do the development side, because in data science in particular, you're typically like producing like an output, like a model that you want to get into production, and being able to like heal a pipeline or be able to kind of like monitor and like retrain models are things as well that I think agents could be useful for. So I think ideas and being like a creative, understanding like data, its limitations, and evaluating like results are like all things that the human still does. They probably write less code and hopefully do like less debugging, I would say.
Yeah, I'm very optimistic about the improvements that these models have been making. I think the difference between like a ChatGPT, 3 and 5 is pretty remarkable.
Mm.
And so I'm focused mainly on getting the user experience right. Like, how can I make this thing as easy to use as possible? Because I know that the models are going to get better, and they're just going to become easier and easier to kind of integrate into your life and workflow and coding and all that jazz.
Yeah, no, it sounds yeah, the user experience is like actually a really interesting one in terms of I don't think the final form has been there yet. It's kind of been an evolution of like the traditional like coding experiences, be it the Jupyter notebook or like the VS codes that have like IDs like put onto them, or like agents kind of like embedded and put onto them, which is a very good starting point because there's like a familiarity for like the the users. But yeah, I can see coding looking a good bit different, and people maybe using like more natural language to kind of like do things as the people get more comfortable with the tools, and they're able to like work for longer.
I was listening to NPR the other day, and I heard a story about a woman who had fallen in love with ChatGPT, and it it was an awesome story. But her problem was that after she'd spoken, like been talking to him, ChatGPT for like 3 or 4 days, it would forget who she was because of this context window. Can you define context window just so people kind of understand, in case anybody doesn't understand what that is and how it relates to what we're talking about?
Sure. So in your large language models, these kind of like they're basically just like predictors. They take a set of like input tokens, which are like characters of like a language. So English, German, it could be any kind of language, and then it goes through this model. The numbers all get crunched, and what it produces is like a prediction of like the next set of like characters. So it kind of like takes in one set of characters and it produces another set. So the context window is that input set of characters. So that can be so context is effectively what you input into it, and you have two different types of inputs. You've got the system prompt, which is the instructions for the model, so kind of all of the background information that the user doesn't typically see, and then you've got the message history. So this is like what the user types in, what the model responds with, and then when the user sends the next message, it's got all of the previous messages, so they can effectively output the next set. So it's yeah, the limit on the characters that can go into the model, and there is a limit. So there is like an upper limit. They are getting bigger. So it's like the larger like Claude models are 200,000, and there's one that has like 1 million characters now.
Characters or tokens?
Oh, tokens. So it can be it's like you typically get 3 to 4 characters in a token.
Wow. So that's huge. 1 million tokens is a ginormous context.
Yeah.
Got it. So when I send in a prompt to ChatGPT, it's getting more than just the question I asked it.
Oh, definitely. It's having all of the instructions, like how it should respond. Should it be like playful or not? Should it like tell joke? All of those kind of things are like hidden inputs into the model. And then when people use it in a business context, it'll have that information around like the task that it's doing. The coding agents will be told like how they should react, what kind of language they should use, and any kind of like pitfalls they might fall into. So it's like make sure that you're like checking your syntaxes, all of those kind of all of those like extra things that make the model behave well. And there was actually an interesting thing I saw earlier. So just for one of the demos earlier, I was kind of playing around with a financial data set, and I wanted to do some like encoding using one of the large language models, and there was a fine-tuned one called, I think it was like Finbert or something like that, on Hugging Face. And I was working with the Zerve agent, and I was like, can you do the encoding? And it came back and said that actually people have shown that using GPT 4.0 with just like proper or just like that context, like additional context, outperforms the fine-tuned model by up to 10%. So wow. Not something that I would have thought of a year ago, where a fine-tuned model on like financial data sets would do worse in terms of if you take a general purpose model and just give it like specific context related to the task. It ended up outperforming it.
That's wild. So the general all-purpose models have become so sophisticated that they're better than some of the more narrow.
Yeah. So
models.
I wouldn't have guessed that even 6 months ago.
Huh.
I wouldn't have guessed it today, I think. But there you go. Yeah.
All right. Well, hey, let's jump in. Maybe we'll start with Cursor, or one of the other sort of coding agent tools that are out there for more engineering and software development purposes. Do you think you could show us, just pull it up and give us some examples of how the agent helps with writing boilerplate or doing code completion or something like that?
Yeah. So so for this, I just have like a sample project, and tell me when you can see the see the screen?
Yep.
So this is Cursor. It's a very, very cool software development tool. It runs locally. You have access to the terminal. You've got the agent and kind of like chat functionalities over here. And to start with, because it's a data science kind of a project, what I'll do is I'll just ask it to create a Streamlit app. And I've taken a Kaggle data set that has like global temperatures here. So what I expect Cursor to do here, and what it does like really well, is that it's going to like create a to-do list. So it'll like examine the files that I have. It'll create the Streamlit file, probably put it in my file system here, and then write all of the code. And you can kind of see that it's like working through this to-do list. It's reading all of the files, and it'll kind of like do everything from like running it. It's now going to create this temperature dashboard.py, and this kind of stuff I think is like Cursor is like excellent at, and this is kind of like scratching the surface in terms of like what it's able to do in terms of like working with like large file systems, because what it does under the hood is that when you have give a Cursor access to a code base, it'll index it all, and then it's able to like intelligently search it, so that if you have a question about your code base or you have some related code somewhere else in a file that you're looking at, it's able to go find it, get it, put it into its context, and then kind of like take that into account when it's coding. So I'm sure here, if I opened it up,
now
we
while
can
it's
see it being
thinking, let me ask you a question while it's thinking. I'm sure a lot of our listeners know what RAG is. Retrieval augmented generation. Is that right? I always forget what the A stands for.
Yes, yeah, augmented.
Yeah, okay, awesome. So that's when you ask a question and then your agent performs some sort of a search to pull in information to add into the context. I guess the alternative to doing that in this case would just to include the entire code base in the context rather than searching it first.
Yeah, and you'd have issues typically with even the million tokens probably isn't enough for like a large code base. So you do need to do some level of like RAG or retrieval, and that's something that I think Cursor spent a lot of time doing. Was kind of like getting good search and indexing for dealing with like large code bases. Gotcha.
Now, one of the things that I've seen as I've played with some of these tools is that when I'm using a public data set that I downloaded from the internet, like Titanic or like the global temperature ones, that the models almost seem to know what's in the data to start.
Yeah, it's actually, I've got an interesting one when we get onto Cursor for like notebooks and data science, where it did some like interesting things based on not necessarily based on like what was in the code or what it did, but more so on what it expected it to do in terms of like some of the insights that it produced. So there is definitely a thing where if you have like a popular data set or like a well-known code base, because the large language models that are being used are trained on the data effectively, it's got it like stored in its memory, and then it's able to just be able to output it. So it doesn't need to really write code or we'll say like run the code to be able to like answer some of the questions.
So if you're benchmarking these models or the coding agents using a public data set, is kind of like target leakage. It's like cheating.
It's definitely. It's like you definitely have like you said target leakage, where it just has some. It's in its training data. So these are just models at the end of the day that have been trained across like most, if not all, of the internet. Okay,
good. Okay, so the coding agents that are actually doing this work, how is what something like Cursor or Zerve's agent how's what it's doing different from just copying, putting a prompt into ChatGPT and then copy pasting the code into a code editor and running it?
Yes. So I think there's kind of like two things. So one is the context, and then the other one is like what's called like tool calls. So this is the ability for it to like do like actions. So instead of it just being chat, one of the things it's able to do is like respond with like an instruction and then be able to like execute that instruction. So it could be everything from like reading particular files to writing code to running like terminal commands in this case. So at this point, I think our Streamlit app is like done. We can copy the command and we'll get an app like up and running. So this is kind of like an example of where I think cursor shines. And even if you were to do something like change it to like light mode, I think, yeah, so these kind of like applications is like super good at. So it's like script based. It's got it's able to kind of like edit the code, the styles, and these kind of like server based applications actually have like hot reloading like baked into them effectively. So when you make a code change and you accept it, it'll automatically like hot reload, which isn't necessarily the same kind of like execution models that you have when you're working with data, I would say.
There's a question here in the comments. It says, what safeguards exist to prevent coding agents from introducing insecure or biased code?
It's actually down to the systems that like implement them. It's like around like guardrails. So it's like you can kind of bake in guardrails, so you can have like multiple agents would be one thing, or you can have like evaluations that are more like deterministic. You can imagine you have like a coding agent, it produces an output, and then you have an evaluator that has to like make sure that it has certain like accuracies, certain we'll say like coding practices before it can accept the answer and then like progress. So kind of LLMs as a judge or guardrails would be the typical approaches that people would take to date.
So there's a bit more risk when the agents start to have a bit more power.
Oh, definitely. Yeah. And there's big issues if you give it like access to like production databases or anything like that, because they can like, if they have access to things like the terminal, they could like delete files. Systems like Cursor do kind of prevent it and have like allow lists of certain commands that they can run. But there's definitely more risk the more like autonomy they have. There's sometimes less risk if you can run them in a sandbox environment, and you have things like if they do have to work with the database, that the credentials they have are like read only, and if they're not able to like access certain parts of your file system, that means that it's, even if they do try to do something bad, they don't have like the actual permissions to do so.
Gotcha. Okay, let's shift gears a little bit and talk a bit about data science. So why can't, what are the issues when it comes to using something like a cursor for a data science project?
Yeah, so this is kind of like my experience of it. So so in this case, same data set to just keep it simple, and I asked it to do like EDA on my files. So what it's perfectly good at is like code generation. But in the case of like a notebook, what it doesn't have is like the ability to execute the code. So if I ask Cursor to run the code, typically what it'll do is like, if I say like run my first cell in my notebook, typically what it tries to do is like take the code here and run it as a Python script in the terminal. So it doesn't do the execution, but when you ask it to do something like, so it's going to activate, and okay, so that's like typically what it does is it doesn't have like access to the kernel itself to run it, and it doesn't have access to the variables or the state, because it's like optimized for larger code bases. And we'll say,
and data science is a bit more iterative, so
definitely.
You kind of want to like loop, yeah.
You want to be able to run it, look at the code, and be able to then write your next piece of code based on what not only the code in the cell, but what the outputs were. You should debug it before moving on. So when I asked Cursor to do like EDA on my files, just keep it simple, it wrote. It did read the top of the CSVs effectively, so read the top of it to get like some information, and then it wrote 9 cells but didn't run any of them effectively. But what it did do is it produced some like key findings. And I then asked it, how did it like find key findings without it being able to access without it like having executed the code. So what it did then was it kind of like reproduced some of the code cells again, because I was in agent mode. But when I asked it again, basically it kind of touched on your point earlier. So I just asked it, how did you get the insights without having run the code? It said it was a good point.
So it's kind of hallucinating a bit.
Yeah, so it read the file structure. It had like domain knowledge applications, and then like what it called educated like inferences. So just like the fact that it knows that like there's global warming, there's certain things. So it produced some insights without having like run the code that were effectively hallucinated.
Got it. Okay, so it's a bit like trying to use a VS Code for doing data science manually, right? You typically
so
iterative process, and you want to be able to see your results and react to them and so on. That's just difficult in this environment.
Exactly. Now it still has like some usefulness. It can write the code. You can still like ask questions of the code. You can do like code completions, things like that. But in terms of like an agent kind of going end to end to be able to like do autonomous work, that's the ability to execute the code and like work iteratively are kind of like two things that currently for me are kind of downfalls for working on like data science projects.
And this is all running locally, yeah?
This is also running locally. So it's
Gotcha.
like, so that's actually another good point in terms of like a lot of the times you do want to be able to like burst onto the cloud to use like GPUs or other kind of like larger computes, which you can do through SSH, but you still have to set up a remote environment.
Gotcha. Okay, let's switch to Zerve. Can you talk to us a bit about kind of what the inspiration behind Zerve's agent is, and why we don't think that there's been sort of a cursor moment for data science yet?
Sure. So I think fundamentally there's some just key differences that we've touched on a little bit in terms of like software development and data science. It's everything from how you execute the code. So that is like it's more iterative, exploratory, which is why notebook environments are popular in the first place. Is the ability to be able to write some code, see the results, and write some more code. Which is like super useful workflow. It has some drawbacks around like state management, stability, things like that. But in general, it's like how most of the world does their data science, and for good reason. Then there's the data and the code are also like important. So when an agent is running the results, the types of data it's produced are all like it's super important context. So if you have just a file name, knowing the data types, knowing the types of like if there's mixed data types in a column become like very important. So you're able to like convert them or handle all of the different like intricacies of your data sets, how you should join them, things like that all take loads of time when you're like starting projects. The types of code you write are like different as well. So just typically software, it's kind of like a more closed system. You're following like patterns in the code. Whereas in data science, you probably have less of an idea to start and you're leveraging a lot more third-party packages. So hard to imagine doing a data science project without using like pandas, NumPy, TensorFlow, some of those like packages. So you have to learn how to use those. You have these kind of like concept around using like vectors for like parallelizing your operations more so than you would do in like your typical kind of code basis. So there's probably 101 other different differences as well, including even the the deployment kind of like cycles and how you like monitor them. So model deployment is like very different than your typical software deployments, and CI/CD practices, monitoring, all seem to be very different. So software engineering typically has very standard practices where it's a bit more fragmented in the data world. One other thing actually that just springs to mind is it's a lot more like non-binary. So code compiling or like a test passing isn't like necessarily the how you assess like a data project. You've got to kind of just when you're assessing like the quality of model, looking at things like data leakage, like being skeptical of having like 100% accuracy, things like that are all far more subjective, probably.
Sure. Like missing values. How you handle missing values is going to depend on the shape of the data, how much of the particular variable is missing, its relative importance to the analysis that you're doing, like lots of questions about context questions, like subject matter questions that are going to impact the way you handle that particular column.
So
what about, sorry, go ahead.
Sorry, go on, Greg. Oh, no.
I was just going to go to a question that somebody asked in the comments. They said, how does Zerve handle scaling context across large data sets and long-running workflows without overwhelming the model? So I guess maybe to say it another way, what's in the Zerve context that's different from like a cursor and that sort of thing? And what happens when it gets big?
So maybe what I can do is kind of like bring up Zerve, I guess, at this point to just kind of show it and introduce it to people, and then we can talk around some of the information that goes into the context.
Okay. I love this program.
So this is Zerve, and this is the just to keep it like apples with apples and kind of a comparison. What we have is the same data sets that we had from Kaggle that we had in our cursor example, and we've given it the same instruction. And in Zerve, what we have is, so this effectively produced a 4-step plan. When it was running, it actually ran for 15 minutes non-stop. So
what did you ask it to do to start with?
Do EDA. So
same request.
Same. So it was a data quality analysis, exploratory statistics, correlations. So in Zerve, what you have is a DAG. So each of these are code blocks. You can combine them together. So you have Python R that can work like interoperably. You can connect to data sources. You can mix in GenAI and like a whole host of other kind of like block types. So in Zerve, what kind of like happens different, and we'll show, maybe we'll kick off a work, the agent kind of coding in a minute. But the difference is when a block is created, it'll also execute it. So it'll take the context that it has available to it is anything that it puts in the output, visualizations it creates, any of the data or the data frames that's been created. So each of these are available to the agent. So when the agent is running, what it'll do is it'll use like multiple tool calls. So while it's working, it'll decide to read a certain output, summarize its results, keep it in context or not if it's relevant, be able to access the outputs, so the metadata about the different variable types, or read the variables directly from the state.
So Zerve actually dynamically sets its context based on what the result looked like?
Exactly. Yeah.
That's and it's cool. I actually didn't know that.
Yeah. So it's and it does it at each of these steps. So it's able to reset its context and be able to kind of based on the different blocks, kind of read variables, the charts, the data frames, or the code or the output. So each of the models that we use, so both of these models actually, we use the same model in Cursor and in Zerve here, so it's Claude 4 Sonnet was used. But here you can kind of see it does some kind of like interesting things where it as it goes, it creates like all of the analysis, and then this is like information that's available for the next block when it's continuing on its like analysis. So before it ever does the correlation, it has all of the statistical information, we'll say, that's available, and then when you ask it to give something like the insights, here it's able to kind of give information based on what it's like the code that's been executed.
Got it. So instead of like making it up based on what it thinks is going on, it's actually running code at each step along the way, and then the results from each block pass to the next block and so on, and the agent is reading that output and summarizing it into results here.
Exactly. Yeah. So that's kind of the core difference for like data science workflows here. It's the kind of the execution model, and there's kind of a fundamental difference, I guess, in terms of like where it executes. This is in the cloud, versus it being local, which means you can kind of like have these running kind of in the background. You can be working on another task, and it's able to just work for longer without kind of hogging any like resources on your local machine as well.
Gotcha. How big is the Zerve agent's context window?
So it depends. It's limited by the model that you're using. So if you're using Sonnet, I think it's 200,000 characters. Typically, our context windows end up in the 15 to 20,000 tokens, I believe.
Gotcha. Just depending on the size of the project and the complexity and so on.
Yeah, how many tool calls it's done, how much like relevant, like so the longer it goes, typically you have like longer context build up because it has like information about like the task that it's already performed while it's been working. There is techniques as well to like compact it, so you can even you can just summarize, feed the context window into a large language model and have it like effectively condense down the information so that you can turn a larger context window into a smaller context window for it to continue.
Gotcha. I actually saw a paper published not long ago about compression and hallucinations and being able to run a test to see if a hallucination was actually happening rather than having to read and sort of evaluate your the actual answers. I haven't fully sort of internalized how that works, but that's got to be related, yeah?
Yeah. Oh, definitely. And I've seen it a few times actually where you where it does like compact and condense the context. It can often go off on a tangent immediately afterwards. So it's picks up something that it shouldn't from it's like you told it not to do something previously, and then as soon as it gets like condensed, it'll start the thing that you asked it not to do.
Awesome. Okay, challenges. I want to talk about engineering challenges for building this thing. What do you think was the hardest thing, or maybe one or two of the hard things that that you guys encountered when you were building the agent and getting it to perform reliably?
There's been a few. The initial one actually was probably just structuring the code base to be like agentic. So it's we had kind of written the code over like a couple of years. It was like a standard like backend that has only one way of like communicating with it. It's like somebody would press a button on the front end, it would make an API request, and then they would like update a database or take some action like running a block. When you want both the user and the agent to be able to do it, you got to like restructure and rethink about your code, because now you want the agent to be able to do it as well as the user, and ideally you want to be able for them to be able to do it at the same time. So when a user does something while the agent is working, you want the context to be updated. Then so that was definitely one.
So that's like a plumbing and orchestration type issue.
It's just that's mainly like orchestration.
Gotcha.
There was small differences between all of the different like model providers. So like prompt engineering to get it to work from like one model to another when you're because basically it is for the most part the context that you're providing to it, and they've all been trained slightly differently. So having it be able to do that is, well, like be able to easily switch across like model providers is somewhat of a challenge. UI UX is always a challenge, I think. There's always
I
things that
remember,
we can.
I remember, sorry to interrupt. I remember when I first started testing one of the early versions of the agent, it kept swallowing all the errors. So
Yeah,
it would write logic in to say, try this. And if it doesn't work, just assign these dummy variables and just keep going as if nothing went wrong.
oh, it did it all the time. Try excepts everywhere. It was like yeah,
The
or
LLMs are just so eager to please.
oh, it's a big challenge. That's actually a super good one, Greg. In terms of they do want to just like give you a good like positive. They're kind of like yes men in that sense. So it's like getting it to actually stop when it can't do something is like a big challenge. So especially when you're working with data, it's like mightn't be possible. With you asking a question and the data set isn't available, that's an issue. And a related one is uncertainty with like working on a data project. So you have a file, you never looked at it before, you say I want to do like a model training. If you ask like an LLM like what the steps it should be, or like an agent what the steps should be, it could make like a to-do list of like 8 things, and in reality it could fail after the first one. It's just like not feasible, should change the approach. But oftentimes what it'll do is it'll just continue like nothing is wrong. So getting it to the which was one of the questions earlier around like the safeguards and the guardrails, those kind of like checks, the adaptability then to update the plan and give like good useful information to the user is like critical.
So, okay, future. Let's think about the future, because I've been seeing like code complete and stuff like that for a long time. And my first action was always to turn it off. And because it's just annoying and it never really worked very good. That was, of course, before the agents and the LLMs and stuff like that. But now, like, as I was scrolling through LinkedIn this morning, as I was, kind of getting ready for the day, I'm seeing guys come on and say the same stuff, right? These crusty engineers going, all right, show me a product with AI and I'll, my first question will be, how do I turn this off so that I can get back to my manual coding? When I was the chief customer officer at Data Robot, we invented automated machine learning back then. And that was a lot of the response that we got. It was like, I don't want an automated machine learning system. I want to build my own machine learning because, I know best and I know what's better and all that sort of thing. Do you think this large language model stuff is kind of like that? Like, is it going to be a flash in the pan and people are going to realize, hey, the emperor's got no clothes and this thing is just a fancy autocomplete and it's never really going to work? Or is it just going to get better and better until it's like legitimately replacing people's workflow and stuff like that?
So I think even if it didn't get any better, it's here to stay is what I would say. Even if it doesn't get much better than fancy autocomplete, because it's already a big productivity gainer. There's probably like three different types of people that are like facilitated by coding agents. There's like the experts for their productivity. There's non-domain experts who have like access to things. So think like Lovable for like front-end development, and then there's like educational purposes. So it's you can ask as stupid a question as you want and it'll give you an answer and explain things to you. It has like unlimited patience and can show you like new techniques for doing things, which is probably where Stack Overflow didn't work and people would ask like their as small and silly a question as they wanted to like ChatGPT.
Yeah, Stack Overflow wasn't the most friendly place for stupid questions, was it?
Yeah, it was a terrible place for stupid questions. What it was,
they haven't taken that website down yet, have they?
No, it was back to last year. I think it was back to like back to like late 2010s kind of levels of traffic, I think. So prediction is, I think they'll get better and better. they haven't. I think the innovation hasn't slowed down in terms of the just how good the things like the context windows get. There might be some like cool developments, hopefully in the relatively short term around like reasoning and like how they do like thinking time at like inference, which could be cool. But yeah, I think will it replace everybody's workflows? Probably not. Could it automate some of the tasks? I think it probably could.
We got a couple of questions coming in from LinkedIn. One around how does this help you with data modeling, and the other one around how does it automate ETL data pipelines? It's kind of two questions in the same category. You talk about ETL a bit.
The ETL bit, I think, is actually where it's like so EDA, ETL, all super like interesting. There's one thing I'd like to see probably more of with the agents, something that we're looking at is data discovery. So understanding kind of like database structures, being able to like potentially like index them so that you don't have to do the same like iterative steps to like understand the tables. Is something that I think is like potentially like very valuable. But ETL pipelines, I think, it's a very good application for agents. Zerve is particularly good at it because it's set up as a DAG, has like parallelism. I'd say give it a try. So you can go to app.zerve.ai, try it for free, give it a prompt and see if it can build a ETL pipeline. On the data modeling side as well, I think there's some work to do there for agents potentially to work on like really large databases, just to get the data discovery integrating with things like data catalogs definitely helps to provide context. But in general, I'd say working with data, and if you write code to work with data, it definitely should be a productivity gainer, if nothing else.
Well, yeah, like Jason said, Zerve.ai will get you a free account so you can get on and play around with it, kick the tires, see what the agent can do for you. We did mention the university programs that are teaching data science, and there's definitely an application there as well. Zerve was designed to be self-hosted, so you can install it in your own cloud environment, so your data doesn't ever have to leave your VPC. So it's great for secure data as well. We would love to get folks on there, and even more folks on there, experimenting, kicking the tires, sending us feedback. And just benefiting from the way the agent works to deal with data.
Yeah, and on the ETL pipelines as well, there's like full scheduling built in and a Git integration, so you can version it and schedule it to run. So once your pipeline runs, you can have it run with a custom cron expression or every hour or every day.
All right, last question. We're out of time here. Give us your biggest wish for agents in the next year or two. I'll do mine, and then I'll give you a second to think about it while I talk about yours. Here's the thing that I want the most, and that is the ability to cleanly interrupt an agent's process and say, hey, I forgot this in my prompt, without sort of it losing its place or having to start from scratch. I don't think any of the models have really gotten that down right. I know you can do some of that inside of Zerve, but I really want to be able to interrupt, because that's sort of how I communicate. And I never remember everything that I need to include in the prompt.
100%. That's a killer one, Greg. That's a really good one. So I won't top that one. Being able to interrupt is one of the top things. I'd like agents to be able to ask me questions proactively, I think, is like one of the things. So if I need something, or need something, that there's like a really clean UI that like tells me, and then it's able to continue. So it interrupting me instead of me interrupting it, I guess. And then custom outputs for like data projects, I think, is something that I'd really like. So if I have like to be able to say, I want a PowerPoint, I want it in this format, I want it in that format, that it's able to do it in my my own bespoke kind of like formats and things like that. So if I say this is your template, go off and like create this, I think that would potentially save a lot of time.
Well, judging by the way things are going, I don't think it'll be long before both of those things are completely within reach.
Yeah. So it's yeah. So and do you have a favorite agentic tool at the minute?
Oh, besides Zerve?
Besides Zerve? Yeah.
Ah, man, my ChatGPT knows so much about me. I have tried Operator, so I think they actually turned off Operator
Yeah,
when they
they've changed it
released
to the
ChatGPT
agents,
5.
I think. Yeah.
Yeah, so I thought Operator was cool. It was a little slow, but I asked ChatGPT the other day what it knew about me, and it was alarming, the things that it
Oh,
knew
yeah.
about me. Got a few details wrong. I posted it on LinkedIn, actually, but yeah, I have a deep personal relationship with ChatGPT.
Oh, very good.
What about you?
Is it my ChatGPT is my go-to one at the minute, I would still say. I do like I've tried Comet, the Perplexity browser. It's
Oh, Grok is
pretty.
hilarious, though. I like about Grok that it's unfiltered.
Yeah, that it just
Sorry,
it's
I interrupted though.
oh no, that's a good one. Yeah, it's and on it, it's actually so they've done a really good job. Like yeah, 2 years ago, would we have thought there'd be like so many like good model providers, and even like some of the open source models are good. So it is yeah, the variety in it and having like choices for like the different large language models, I think is a big win in general for everybody.
Nice. All right. Well, I think our time's about up, but thanks for all the insights, Jason. Jason is the true brains behind Zerve. He and the engineering team have built something truly remarkable, and it's a privilege for me to get on there and use it and piddle around and have it amplify my ability to write code. And I'm just super excited for where we're going and what we're building, and I can't wait for everybody to get a chance to try it.
Yeah, so Greg's underplayed his role massively there, but it's yeah, no, been a pleasure, and yeah, with yeah, like Greg said, getting people in, trying it, giving feedback, and seeing what people build, and yeah, if people want to continue the conversation as well, there's a community Slack channel that they can join as well.
Excellent. All right. Well, in that case, let's sign off, Jason.
Yep, thanks very much, Greg,
All
and
right,
thanks very
thank
much
you.
everybody for tuning in.